Okay, in this section, we're going to talk about measures of relative standing and box plus. This corresponds to the book in chapter 2, section 2, and chapter 2, section 3. So far, we talked about sample versus population. How do we pick the sample? And once we have a sample, how do we organize the sample? This section, we're going to talk about one of the ways we can analyze the data that we collected from our sample. So first thing we want to look at is this is called measure of relative standing. So what does that even mean? Let's say I played video game and I score, let's say 140 points. Okay. So my question is it a good score? Is it not a good score? What is it? I guess we don't have enough information because 140 points out of what? And also another question is it a good score compared to other people? Is everyone getting more than 200 points? Then 140 points is not a good score. But what if everyone else is getting like 60 points, 110 points, 120 points? Then 140 points is a pretty good score. So sometimes number itself doesn't give you the whole story. We're going to kind of look at like how is this number compared to other number. So this is what we're going to talk about today. So it's called measures of relative standing. Relative just means compared to other people, compared to others, right? And standing is kind of like a ranking. This is almost like a ranking or your position, right? So we're kind of interested in it's like how am I doing compared to other people? Like what is my ranking? Okay, one of the first thing we're going to talk about is the median. Median is the data value that is in the middle of the data set if the values are arranged in order. We're going to usually do it as increasing order. That means from the smallest to the largest, increasing order. So what we do is once we have our data set, we're going to arrange them in increasing order, means smallest to the largest. So imagine I have 5 students. Here, maybe I can give a graphical representation. I have 5 students. Let's say I want to arrange them according to their height. So number 1, number 3, number 4, and number 5. Number 1 ranking in terms of height. Alright, so I have 5 students. So median is basically the person in the middle. So I'm like obviously number 3 person. This person is right in the middle. This person is not the shortest. This person is not the tallest. This person is like a middle person. So in statistical language, you're going to call that a median. So whatever this person's height is going to be the median. So to find the median, if you have odd number of values, we basically pick the middle person, pick the middle element or data value. Let's call that data value. Okay. If it's 5, it's pretty easy to count. What if I had numbers 1, numbers 2? What if I have like 75 people, right? It'll be a little hard to see where the middle is. So this is what we're gonna do. We're gonna do, if I were to do it a little more systematic way, I'll do 75 divided by 2. If you calculate that out, you're gonna get 37.5. I'm gonna round that to 38. That means I'm gonna look at ranking number 38. So if I happen to have 75 people, I'll get person ranked number 38, and the person's height will be the median. Same here, I knew it was going to be number 3 in our original example. If I was going to do that for a little more systematic way, I could have done it like, oh, we have 5 people, so it's 5 divided by 2, because I'm splitting it into half. I'll give you 2.5. So I round off to the number 3, and that's where we looked at. Alright, what if we happen to have even number of people? Then there's one more step we have to take. So let's say I have now, instead of 5, 6 students. 1, 2, 3, 4, 5, 6. I arrange them according to their height. Number 1 is the shortest, number 2, number 3, number 4, number 5, number 6 is the tallest. Well, in this case, there is no like one middle person. There are actually two middle right here, number 3 and number 4. So basically what we're going to do is we just average them together. So what we're going to do is pick, we're going to have two middle data values, then average them. It just means add them up together. So basically ranking number 3 plus ranking number 4, so I'll divide that by 2. Okay, that's how I'll find the median value. If I'm a median person right here, if I'm this person, basically like half, I'm like right in the middle. That means half of the data set is shorter than me and half of the data set is taller than me or larger than me. So median was when we divide our basically data set into two portions, like half. Quartile, as the name says, quart means 4. Quartile divides our data set into 4 groups of equal size, right? So instead of half like median, we're going to split it into 4. So the first quartile, Q1, separates the bottom 25% from the top 75%. This should be saying the second quartile, sorry, there's a typo here. The second quartile, Q2, separates the bottom 50% because 25 plus 25. So that's 50% from the top 50%, which is basically the median that we talked about. And the third quartile, oh wow, Q3 separates the bottom 75% from the top 25%. So here, for quartiles, you're splitting your data set into 4 groups instead of 2 groups. So minimum means the smallest number. This is Q1, Q2 is right here, and then Q3 is right here, 25%. So like each segment gets 25%. 25% here in this segment, 25% here, 25% here. That was the concept of median and quartiles. In terms of practicality, we're going to use our calculator to calculate those values. So please refer to the separate link that you'll see for how to use calculator. One of the applications for quartile and the median is outlier. To find the outlier, outlier is the number value that is either too big, value that is too big or too small. So this is somewhat unusual values. Unusual value. In order to find our outliers, first we're going to do interquartile range, IQR. IQR is just Q3 minus Q1. So third quartile minus the first quartile. And how do you identify outliers using IQR? I'm going to draw a little number line. So we're going to come up with 2 values. So what we're going to do is, in between these 2 values right here, I'm going to say these are like normal values, not too big, not too small. And once you go past this point, we're going to say, oh, these numbers are too big. So we're going to call that outlier. Outlier. And also to the left as well, oh, these numbers are too small. They're also outliers. So these are my cutoff. Cutoff. So we'll find 2 numbers right here and right here. And in between these 2 numbers, we're going to say these values are normal values. And once you go past those numbers, we're going to say those numbers are outliers. Okay? So go back to Q. So first thing we will do is find IQR, Q3 minus Q1. Then we'll calculate two numbers. The first one is going to be high cutoff. So that will be calculated by Q3 plus 1.5 times IQR. And then low cutoff is going to be Q1 minus 1.5 times IQR. So I'll calculate this number, I'll calculate this number. Those two numbers are going to determine these 2 points right here. And once you go past those two numbers, then we have outliers. Now I'm going to have you pause and work on number 8 and number 9. So far we have looked at median and quartile, where we divide a group into half and into 4 groups. But what does it have to be 2 or 4? Can it be just a lot more? So percentile divides our data set into 100 groups of equal size. Percent again means 100, right? So kth percentile, pk, separates the bottom k percent from the top, 100 minus k percent. So what that means is, let's say we have 90th percentile, right? That means we are somewhere over here. It separates the bottom 90% from the top 10%. So if you're 90 percentile, that means your score is pretty high compared to other people. 90% of other people have lower score than you do, and 10% of other people have a higher score than you do. Okay, now I'm going to have you work on number 11 here, but I kind of want to do the first question together. So on a 60-point written assignment, the 80th percentile of the number of the points was 49, right? Interpret the 80th percentile of the context of the situation. That means, let's suppose you got 49 out of 60, and you happen to be 80th percentile. That means 80% of the other people did worse than you. So here I can interpret it as a 80% of the data set got lower score than you did, has lower than 49 points, right? So if you had 100 students, 80 of them will have lower score than 49. On the other hand, I can say that 20% of the data set has higher than 49 points, right? If I were to graph it, you're 80 percentile, so you're probably somewhere here, you got 49 points. That means 80% of other people in the class or in the data set is lower than you, and 20% of other people who are in the data set is higher than you. Okay, and I'm going to have you pause and look at work on number 11 and number 12. Okay, now we're at number 13. Box plot is just graphical representation of what we just learned. So what we need for box plot is minimum, which is the smallest number, and we need maximum, which is the largest number, and then we need a Q1, Q2, and Q3. And Q2 was same as the median, right? So what I'll do is we'll take these 5 numbers and then we'll put it in terms of graph. Okay, I'm going to do my own example. Let's say I have a data set and I calculate the minimum was 2. I'm just making it up. Q1 is 10, Q2 is 12, Q3 is 15, and then Q5, oh, there's no Q5, max will be, let's say 18, something like this, right? So the way I'm gonna, so I have these 5 numbers. So I'm gonna make box plot is that first. I need to scale all my numbers. So I'm gonna draw the line. So I noticed that the minimum is 2 and the maximum is 18. So basically my data range is between somewhere between 2 and 18. So when I scale my number line, I want to make sure it covers all my data. That means I'm going to range from 2 to 18 or including 2 to 18. So maybe I can start from 0. I can go to 20. So there I want to make sure that it covers 2 and 18. So I want to scale it evenly. So if this is 20, the halfway is 10, then this is 5, and this is 15. So I'm making this number line. I want to make sure they're consistent. This is 5, another 5, so it's 10, another 5 is 15, and another 5 is 20, and then distance is all even. That'll give you most accurate representation. So my minimum is 2. Minimum, I'm going to put a little dot. Maximum is 18, so 18 is something like right before 20, so that's another dot. And I'll take the middle 3 numbers, and then I'm going to go 10 is here, 12 is here, about here, 15 is about here. So I'll draw a box with those 3 numbers. So that's 10, 12, and 15. And they branch out like this. So basically the middle 3 number gives you the box in the middle. The minimum and maximum gives you the end point, and then we just connect them like this. And I can label them, this is min, this is max, Q1, Q2, Q3. So I'm going to have you finish the rest of the worksheet.